Welcome back everyone to Learning by Teaching. We're in statics and we're going to do problem 5.22, okay? It says, if the density of the distributed load acting on the beam is W, which is equal to 3 kilonewtons per meter, determine the reactions at the roller A and beam B. So we got our roller at A, we got our L-shaped beam, and we have also a pin at B, okay? We have this distributed load that we can find with the area. Okay, so in order to solve this, what we have to do is that we will have to redraw a free body diagram. First of all, our beam that it looks like an L-shaped beam. Okay, now we will replace the roller by a force that is acting normal to the surface. So basically at 90 degrees, and we're gonna call this reaction A, okay? At beam B, we'll have two reactions, so because it's a beam, so we will have force By and also Bx, okay? Now, this distributed load, we're gonna find a similar resultant force that is going to be equal to that one. Now, how do we find that force that we're going to call F of L, so L for the load? So we find the area of this guy. So we have that the height of these rectangular red forces is equal to 3 kilonewtons per meter. And we're going to multiply by the base. Well, the base is equal to 4 meters. Okay, so we'll find out that this is equal to 12 kilonewtons. Okay, so we can replace it over here in our free body diagram, and it's equal to 12 kilonewtons. Okay, now, couple of things that are important for this free body diagram is that where is this force located? Well, compared, so we have our regular beam on the base from here to B is equal to 4 meters. Now, this force is going to be at 2 meters from each point, from either this one or that one, okay? Now, the other important is what is the angle of this reaction with respect to the x-axis or y-axis. Any of them. So in order to do that, I'm going to draw a similar triangle that is going to be, so it's going to be from the beam, it looks like this, then we have our force that is going like that. So this is my force A. Now, if I complete this triangle, no matter even if I cut a little bit of the beam, this angle is still the 30-degree angle given by the problem. Now, since reaction A is normal to the surface, so this side is my surface, then from here to here there is a 90-degree angle, okay? And what do we know about triangles? Well, the summation of these three angles should add up to 180. So we have that 180 should be equal to my angle theta, so I'm going to call this guy theta, plus 90 plus theta, okay? Now, if we solve for theta, we'll find out that theta has to be equal to 180 minus 120, that gets me 60 degrees, okay? So that's something really important, so 60 degrees, okay, good. I'm going to erase this because we already found our angle that we wanted. Now we need to find A, Bx, and By. So I'm going to start by doing the summatory of moment at point B. So if I do the summatory of moments at point B, what do I have? Well, By and Bx don't have any distance with point B because they are actually applied at point B. So I will have a positive, so if I hold my pin in this position and I apply a force like that, it's going to rotate counterclockwise, so I have 12 kilonewtons multiplied by the distance, which is 2 meters. And then I will have minus, so we're gonna break our reaction A into the y component, which is going up, and the x component, which is going to the right, okay? So, the y component of A is going to be equal to A multiplied by the sine of 60 degrees, okay? Multiply by the distance. Well, what is the distance between, so we have 4 meters, so we're gonna do 4 plus, how much is the distance from here to here? Well, we can calculate that distance because we know the hypotenuse of this big triangle, which is 3 meters. So it's going to be 3, and the angle is 30 degrees. So if we want to know its adjacent, it has to be cosine of 30 degrees. So we're going to do 3 cosine of 30 degrees. Okay, now that was for the y component of A. What about the x component of A? Well, it's going to be A multiplied by the cosine of my angle 60 multiplied by the distance. Well, this distance is going to be the opposite of this triangle. So it's going to be equal to 3 multiplied by the sine of 30 degrees. Okay? Now, the only unknown that I have is this A over here. Okay? So, and all this should be equal to 0. Let's not forget about that. So we will have, if I pass this whole term to the other side, will become positive, and if I pass this other side, this whole term to the other side is going to become positive. So I will have 12 times 2, that gives me 24, will be equal to, and I'm going to multiply sine of 60 by 4 plus 3 cosine of 30. Let's see how much that is. So we got sine of 60 degrees multiplied by 4 plus 3 cosine of 30 degrees, and that gives me 5.7. So I'll have positive, since we move it to the other side, 5.71 of A plus, because remember we moved this one too, and we're going to do cosine of 60 multiplied by 3 sine of 30. So cosine of 60 multiplied by 3 sine of 30 degrees, and that gives me 0.75 of A. Okay? Now, if we solve for A is going to be equal to 24 divided by the summation of these two numbers. So if we add 5.7 plus 0.75, that gives me 6.46. Okay, now all we have to do is divide 24 divided by our 6.46, and it's a total of 3.71 kilonewtons. Okay, so we found A. Good. Now we need to find Bx and By. So for those ones, we're gonna do the summatory of forces in the x direction. Okay. Now what do I have in the x direction? Well, I'll have A, the component of A in the x direction. So I'll have A multiply the cosine of 60 degrees. Okay. Plus Bx. And I have nothing else in my x direction, so this should be equal to 0. So I'll end up that Bx is equal to negative A multiplied by the cosine of 60. Since we know A, we just plug the values, 3.71 multiplied by the cosine of 60 degrees, and that gives me negative 1.86 kilonewton. Okay, this is our second answer. If it's negative, it only means that I threw it in the opposite direction that it is supposed to be, okay? Now, if we do the summatory of forces in the y direction, what do I have? Well, let's see. So I have a positive A in the y direction, so it's A multiplied by the sine of 60 degrees. Okay, good. Minus our 12 kilonewtons plus By. And all this should be equal to 0. Okay, so if we solve for by, we'll find that by is going to be equal to 12 minus a sine of 60. So let's see how much that is. So we got 12 minus the 3.71 multiplied by the sine of 60 degrees. And this is going to be equal to 8.78 kilonewtons. Okay, and we found our third answer. Okay, thank you guys for watching. If you guys have any questions or any comments, please post it down below, and I'll see you guys in the next video.